Hi, welcome to the virtual Open Day presentation from the School of Chemistry at Monash University. My name is Kellie Tuck and I'm Head of Teaching within the school. I'm assuming that you've joined me today because you already have an interest in chemistry. Before I get going with the presentation, I'd like you to ask one question. What is it that you think of when I say chemistry? Do you think of chemists in white coats or blue coats as we've got on this slide and studying the periodic table? I think the periodic table is fascinating, but to me, chemistry is so much more. Chemistry is everywhere. It's all around you, what you see, what you touch, and what you taste. They all involve chemistry and chemicals. This is one of the reasons why we call chemistry the central science. Everything involves chemistry. We do need to know about the discipline of chemistry to understand the world around us, to protect it and ensure its longevity. Chemistry is not just limited to the laboratory, to reagents in beakers, or to the stereotype of chemists in white coats. Chemistry is part of almost every industry and in almost every area of business. That's really something to think about. There's a number of global challenges in the world today, and if you've been watching the news recently, you'll have been able to see a small snapshot of how these problems impact our lives and also the quality of the lives of future generations. Can you think of some of the global challenges facing us today? So here I list some, but I'm sure that you've thought of some which are not here on this slide. So one of the chemical structures on this slide, or the chemical structure on this slide, is of remdesivir. It's quite topical at the moment because of our current health challenge. This chemical was originally designed to treat the virus disease Ebola, but now it looks like it will be able to help with the recovery of hospitalised patients with COVID-19. Unfortunately, antimicrobial resistance is also one of the big threats to humans and animals today. More microbes are becoming resistant to our current medicines. Of course, climate change has been very topical recently, with water levels rising and temperatures increasing. And sustainability, again, is a hot topic. Others which of course are relevant are the supply of energy, the health of our water and our soil, and food security and the world population. These are all excellent reasons to study chemistry. But you may also want to know how things work. You might just like asking questions and love the macroscopic and microscopic nature of chemistry. All of these are great reasons. But how will studying a degree in chemistry make a difference? Well, you can make a difference in many areas. A knowledge of chemistry is needed to fight global pandemics, not just COVID-19, but also influenza strains. Antimicrobial resistance is increasing, and previously, for example, bacterial infections, pneumonia or tuberculosis could be treated with modern drugs. But now they've got resistance, so new drugs need to be found. There's also non-communicable diseases, for example, cancer and heart disease, and these are responsible for millions of deaths worldwide each year. I could be talking to a person in this audience who finds the cure for cancer. New energy supplies are also needed. We can't keep relying on non-renewable sources, and we need to improve the ways in which we store energy. Water is a precious thing. Protecting our waterways is underpinned by a knowledge of chemistry. Chemists also have a key role in reducing pollution, whether that is in the design of more green or sustainable processes or from an analytical perspective, so that we actually have a deeper understanding of what is happening. So, could you be playing a part to ensure that there's food security for our next generation? Maybe this is in the development of a meat-free food, or also in the industrial production of high-quality food for a growing population. Having a comprehensive chemical knowledge empowers you to influence change, to be triggers of change, to find solutions and inspire others. All of these, in my mind, are reasons for why wouldn't you want to study chemistry. So sometimes it can get a bit confusing about what job you do if you are a chemist. I've listed the scientific opportunities for chemists on this slide. The reason why it can sometimes get a bit confusing because there are so many different jobs that you can do with a Bachelor of Science degree where you've got a chemistry major. You can see that with the ones that are listed here, chemist or chemistry doesn't often appear in the job title. Something that you might not know is that chemistry-based manufacturing employs about 60,000 people in highly skilled jobs in Australia. That's a huge number. And as a result, it is central to the country's socio-economical, environmental well-being. New technologies are being created every day to provide solutions in medicine, energy, food, and materials. Some of the career options that I've listed, you might not have thought would be applicable to someone studying chemistry. As a chemist, apart from learning a comprehensive knowledge of chemistry, you'll also learn a wide range of transferable skills. And these include analysis and problem-solving skills, time management skills, handling and analysing data, oral and written communications, teamwork, presenting, and also research skills. The skills of handling and analysing large volumes of data enable opportunities for you in other areas, such as the environment, healthcare, and marketing. How do you decide what is the right job for you? Think about what you are passionate about, and you might find that knowing this will lead you in the right direction. Some of the professions listed on this slide may already be calling you. All right, so you've decided to study chemistry. Why choose chemistry at Monash? Well, Monash University is the forefront of chemical innovations and research. Chemistry at Monash offers world-class research environment and enables you to engage in many facets of this fundamental field of science. If you're interested in a career in chemistry, Monash Science is the place to be. Study chemistry at Monash and join a vibrant and dynamic school. Our enviable reputation places us as #1 ranked school in Australia, and we're in the top 0.5% of chemistry schools worldwide. A Bachelor of Science degree at Monash offers you excellent vocational prospects where we have a real focus on skills for employment. We have a modern, exciting laboratory program, which I'll tell you a little bit more about, and we have extensive experience with some field work and site visits. We have a large range of units within chemistry, and we lead on our bachelor degree to further study with honours degree and the pathway to Masters and PhD. Importantly, we've got an excellent international academic reputation in teaching and research. So majoring in chemistry, why would this appeal to you? Well, if you're interested in science and its application to real-world issues, study chemistry. If you're seeking a strong discipline training that can lead to a career in numerous areas, definitely study chemistry. And if you've got a desire to learn problem-solving skills and analysis techniques that can contribute to a new knowledge and address local and international issues, then study chemistry. Chemistry is the central science. It intersects with many, many other disciplines. We apply an innovative approach to chemistry education. So you will learn and engage with the beauty of chemistry in a curiosity-driven manner within our degree. You can choose a BSc 3-year degree or an honours 4-year degree. And the first year gives you lots of flexibility to be able to choose the other disciplines to complement your major studies in chemistry. We've got a really great science program with the skills which will be integrated to develop communication, critical thinking, independent learning. We've got an engaging lab program and we've got electives, units of choice. So as a student, whether you're an undergraduate or a graduate, you'll benefit from exceptional teaching and training, and you'll learn in that simulating environment that is underpinned by research-led teaching approach. So here I've got on this slide how to enrol in a Bachelor of Science majoring in chemistry. There's a number of different options here, and further information on these degrees can be found within the Faculty of Science Welcome to Science booth. You can also do a major in chemistry, and that can be taken as part of a double degree. So you can choose the Science Bachelor degree, which is a 3-year degree, the Science Bachelor of Honours degree, which is a 4-year degree, Science Advanced Research, which is a 4-year degree, or the Science Advanced Global Challenges, which is a 4-year degree, as well as a range of other double degrees. So I've mentioned that we have an excellent international academic reputation in teaching and research, and our research themes underpin our teaching and our research program. We have 5 themes, and they are listed here. So material science, biological chemistry, molecular biophotonics, environmental and analytical chemistry, and chemical synthesis and catalysis. When I show you units that we teach, you'll see how our research directly links into those. So what does a major in chemistry look like? Well, in order to do a major in chemistry, you, out of your Bachelor of Science degree, 3-year degree that requires 144 points, you must do 48 points of chemistry. And that's detailed as being 12 points at level 1 and 36 points combined at level 2. So on the left-hand side of this slide, I've got the sequence going from first year, so Chem 1011, Chem 1051, through second year, right up to third year, and I list all our units. On the right-hand side, I've got a little bit more detail because not only have I got the unit code, which is, say, for example, CHM 1011, Chemistry 1, I've got the name as well, so Chemistry 1. So at first year, you can choose to do Chemistry 1 or Chemistry 1, our advanced program. In the second semester, you would do Chemistry 1022, which is Chemistry 2, or our advanced version of that. Once you've done 12 points at first year, you come on to our second year units. So I've listed them on this slide. I'm not going to talk about them in too much detail, but just to point out that we've got ones that are in environmental chemistry, we've got ones that are in inorganic chemistry, organic chemistry, analytical chemistry and spectroscopy is talking about analytical chemistry and physical chemistry, biological chemistry and food chemistry. You might be interested to see this unit now, which is CHM 2990. This is our introductory research project unit, and it's offered in semester 1, semester 2, and also over the summer. This unit is a great unit to see how first-hand research and development works. And in this unit, you're actually an active member within a research group, working alongside PhD students. The skills that you develop in this unit include experimental design, data analysis, critical thinking, communicating ideas both in the oral and written space. All of these are really important skills, whether you decide to continue on and take up a research degree or go straight out into the workplace. At third year, we again have a whole range of units that you can choose. We can see that we've got medicinal chemistry, advanced physical chemistry, environmental chemistry, advanced inorganic chemistry, materials chemistry, advanced organic chemistry, advanced analytical chemistry, and sustainable chemistry. All excellent topics to study and all very important to combat those global challenges that we're facing today. We also have 3990, and this is like 2990, except it's an extension. So it gives you a bit more further information about what research is actually about in that space. Again, you can take the skills that you learn onto a research degree or straight out into the workplace. The last unit that I want to tell you about is 3180. This is our study abroad unit, and this unit is a great unit because it gives you the opportunity to carry out a research project overseas in the final year of your 3-year degree study. We've got partnerships with Leipzig University in Germany, the University of Groningen in the Netherlands, Durham University in the UK, and Warwick University in the UK. So these all accept students to go across and do a research project in the labs. The people that have gone, the students who have gone on this, have absolutely loved it, and it's a great thing to be able to do to improve the internationalisation of your experience at Monash. So a degree in chemistry can lead to a range of research opportunities within the school. And I'm just going to briefly talk about these here. You can do research projects at an undergraduate level, an honours, master's or PhD level in the whole range of research projects areas that I have mentioned today. Further, we actually have a master's in food science and agribusiness, and we have a master's of green and sustainable technologies. We have joint PhD programs with the Indian Institute of Bombay and the University of Warwick, the University of Bath and the University of Leipzig. We also have the opportunity for you to do a PhD program with an industry partner, so in that Graduate Research Industry Participation or GRIPS project. The range of research areas are very topical: sustainable and green chemistry, environmental and analytical science, synthetic, inorganic and organic chemistry, biological and medicinal chemistry, food chemistry, materials chemistry, and also in chemical education. It's really important to be aware that Monash has a global reputation and is very well respected for its teaching and its research. So if you've decided to go on with chemistry, what is your next step? Some of you might have found all of the units that I put on the previous slides quite overwhelming. But what you really need to do at this stage is decide what Bachelor of Science degree you'd like to do, whether you want to do a double degree or a single degree. And within the Bachelor of Science, would you like to do a Bachelor of Science Advanced, the research 4-year degree, or a Bachelor of Science 3 years degree, or the Bachelor of Science Advanced Global Challenges? Don't worry at the moment about what units to choose at second or third year. You don't need to choose those until the end of your first year. And you'll find that as you have done your first year of study, you'll be able to get more of an idea about what type of chemistry is talking to you. So what choices you need to make is choose whether you do 1011 or the Advanced Unit 1051. And then in semester 2, whether you do 1022 or Advanced Unit 1052. 8 out of 10 students choose to do 1011 and 1022. So that's a really good thought to choose if you're a little bit confused at this stage. So one of the other things that I do want to note is that our Bachelor of Science 4-year degree in chemistry is accredited by the Royal Society in the UK. So this is really important. It means that our 4-year degree is internationally recognised, and we are the only school of chemistry within Australia who has RSC, Royal Society of Chemistry accreditation. Very important if you're thinking about making that next step in the international space. So where was Monash Chemistry located? I know you haven't been able to come in here today, so I just want to let you know that we're in the Monash Science precinct. The other things that are around us are CSIRO Clayton, the synchrotron, Monash Hospitals, and of course all of the other fantastic faculties and schools and departments within Monash. So again, you haven't been able to see our labs as you're not in campus today. So let me take you through a virtual tour of our undergraduate facilities. Here is the Green Chemical Future Buildings. It's a beautiful state-of-the-art building located right in the heart of the Science Precinct in Monash University. It's a fantastic, vibrant meeting place for students, academics and industry. And it houses our ultra-modern undergraduate laboratories, the tutorial room that we use for our first-year studies, and some of our research labs. We have really exciting, innovative teaching and collaborative learning spaces, and these have allowed us to move away from those traditional lecture theatres and into spaces that encourage active learning and problem solving in small groups. We think our Green Chemical Futures, or GFC for short, hub pushes the global shift towards sustainable chemistry. It unifies teaching, research and industry in all in one location. And in this case, down the bottom or in the breakout areas throughout the building, you can learn, you can network, socialise and collaborate with your peers and also interact with academics. We have excellent laboratories and research facilities with the latest interactive learning spaces. Importantly, our focus is on you. It's on student learning and engaging you. And it's enhanced by our active research culture and our engagement with industry. So here we've got a really excellent building where we've got forward-thinking chemical science. We have each level will take you through the possibilities of what you can do, explore your mind and learn and innovate. In the lower levels, so on the ground floor and first year, is where we have our teaching and our collaborative learning spaces. So you can see that what we've got here are students who are learning in those spaces. These also are our first year labs where we do our chemical experiments as well. It's a really exciting place to be. So why choose Monash Chemistry? Well, we've got really friendly, supportive staff. We have an open door policy with many opportunities for you to engage with us in a small environment, small group environment. We will give you meaning educational learning experience, and we focus on your learning skills as well as knowledge. Monash gives you a lot of extracurricular opportunities, and you've got a great campus there. There's lots of flexibility throughout your study, so you can always value add to your chemistry degree. A degree in chemistry equips you with a range of relevant transferable skills, and even though I've mentioned them, I'll mention them again. These include logical thinking, critical analysis, numeracy, data handling, and communication. And this will set you up for the next career step wherever you may go. A chemistry degree teaches you to think independently, to ask clever questions and devise solutions. Your undergraduate degree can lead you to an exciting, highly relevant research degree in chemistry with world-leading researchers and collaborations with key industry players, but it can also set you up really well for the next step for you to go out straight into the workforce. So choose Monash Chemistry and make a difference. So thank you for joining me today. I encourage you to stay on at the end of this virtual session to ask me any questions that you've got, but also we've got our chemistry virtual booth. So thank you again, and I hope to see you in the coming years.